Okay, actually I'm recording this video also. I hope nobody has got any problem with it. In this interaction, I would be trying to solve one numerical problem, and okay, and that the problem was suggested by one of your friend. I think he is Harshit, and this is basically a problem that was asked in GATE 2018, and it is related to boost converter. So let me uh, let me start doing the problem. Okay, so I hope I'm sharing the screen now. So please let me know, is my screen visible or not? Okay, please let me know my screen is visible or not.
Sir, visual.
Okay, so we will be taking up a numerical problem. It was asked in uh, GATE 2018. So I won't be writing the entire statement of the problem here. I am just okay. Let me allow some more students who are trying to join. Okay. Okay. So I won't be writing the complete statement of the problem. I'm just drawing the circuit diagram. So this is a boost converter, and this is an ideal boost converter. So we have got the inductor and the switch and the diode, and finally it is connected to a battery. On the load side, we have got this battery. This is the load, and the load is battery here. Input is also a DC supply. So input is also a DC supply. Let me call it VDC, and let me call the output as V naught. Okay, and input is VDC, and it is given that input voltage is 50 volts, and this 50 volt DC power supply is used to charge a battery whose voltage is 150 volts. Okay, so it is 150 volts. So naturally, since we are using a boost converter, it is expected that the battery will be of higher voltage rating. Then only we can uh, charge the battery. Then only we can use charge the battery. Okay, so because of this DC boost converter, then it is given the value of this inductor is 5 millihenry. This is 5 millihenry, and other informations that are given are uh, the duty ratio. It is mentioned duty ratio is given, and this is equal to 0.4. Then the frequency is also mentioned, frequency of the switching of this switches. So the frequency of switching is equal to uh, 5 kilohertz. 5 sorry, let me raise it, and 5 kilohertz. Okay, and this is all. These are the informations that are given for the problem. And now the question is, this is a DC power source V1, and this is the DC power source or a battery V2. So the question is, what is the power that is transferred from V1 to V2? So the question is to find out the power transferred from V1 to V2. So this is the question. So I hope the question is clear. So once again, quickly let me tell you what is the problem. The problem is this is a DC to DC boost converter, and uh, okay, this is DC to DC boost converter with input connected to a 50-volt DC power supply, and output is connected to a 150-volt battery. So in between we have got this inductor switch and the diode, which are basically the natural components of a DC to DC boost converter in this configuration. Also, it is mentioned that the duty ratio is 0.4 and the frequency of the switching is 5 kilohertz. By frequency of switching, it is meant the frequency at which the switch is turned on and off. Okay. Moreover, it is also mentioned that the all the components of the circuit, they are ideal in nature, and the inductance value is 5 millihenry. Okay. So let us now try to solve the problem. Okay. Okay. So let's start the solution. So the first thing we would like to see, and please, this is very important, and please keep this in mind whenever you get a problem on DC to DC converter. Don't quickly start using the formula, okay? Because you do not know whether the converter is operating in continuous conduction mode or a discontinuous conduction mode. So I had already uploaded a video on discontinuous conduction mode for a buck converter. Although this is a boost converter, and I would shortly be uploading a video on the discontinuous operation of boost also. But I will quickly derive the expressions that will be used here. So what I am actually telling is that okay, someone was trying to join, no one is there. Okay, so what I am trying to tell you that don't presume that the converter is operating in continuous conduction mode and you start applying the formula of input and output relation of uh, the continuous conduction mode. So this formula of input and the output, the correlation of input and output given by V naught by Vin equals to 1 by 1 minus D is for a boost converter which is operating in continuous conduction mode and not discontinuous conduction mode. In discontinuous conduction mode, the expressions correlating uh, the input and output voltage are quite different. Okay, so the first step is in any problem related to DC converter, first we will try to see whether the operation of the converter is in continuous conduction mode or discontinuous conduction mode. Okay, so how to find out? So there are multiple ways, and one of the way I told you how you can find it out in the video that I had uploaded on discontinuous conduction mode, wherein you can find out the critical value of inductance. If it is more than the critical value, then it is continuous conduction mode, otherwise it is discontinuous conduction mode. So one way to do is that. Other way, the easier way, you could just find out the output voltage uh, from the expression of the continuous conduction mode and try to see whether that voltage is it fits the formula or not. Okay, you could see that input voltage is given, output voltage is also given, and duty ratio is also mentioned. Okay, so more information is given than what we require actually. So just try to find out the output voltage, keeping the duty ratio 0.4 that it is given. So V in is 50, and this divided by 0.4. So this will give you 50 divided by 0.6. So it is 50 divided by 0.6 is I multiply it by 10, and just cancel it by 2. This is 5, and this is 3. And finally, you get 50 into 5 is 250 divided by 3. Okay, so this will be around 8 times, and 10 83.3, something like this, 83.3 volts. So as you could see that this value is much less than the 150 volt that is given in the problem. So that means we are not operating in continuous conduction mode. Okay, we are not operating in continuous conduction mode. In discontinuous conduction mode, the output voltage is larger. The output voltage for a given duty ratio is larger compared to continuous conduction mode. I told this in the lecture on buck converter also. So let us quickly find out what would be the correlation between an input and output voltage for a discontinuous conduction mode. Okay, so let me just bring this up, and let me take red color. Okay, so one thing is clear that the converter is operating in discontinuous conduction mode. So what is meant by discontinuous conduction mode? It means that the current through the inductor, it is falling to 0 before the start of the next switching cycle. Okay, so just see this. Let me draw like this. Okay, so it is 0, and this is your, let me call this beta t time. Okay, this is your dt, this is beta t, and this is your t. Okay, so from 0 to t, the boost converter, in the boost converter, the switch is on, and the current is flowing through the inductor. Okay, so the current is flowing like this, and this diode is not connected, so current is rising. Okay, so from 0 to dt is the time when the switch is on, S is on, while from dt to beta t, so this is the duration in which the switch is now off, S is off. So when S is off, current is decreasing through the inductor and finally reaching 0 before t. Okay, so turn off time is now not equal to 1 minus dt. So this is quite important. Turn off time is not 1 minus d into t. Rather, turn off time is uh, beta t minus dt. So this is the turn off time. Okay, this is the turn off time. Now let us quickly try to find out a relation between the input and output voltage. So in mode 1, so now you could again see there are 3 modes. Mode 1 is when the switch is on here, and then mode 2 is when switch is off, and third mode is when switch is off as well as the inductor is also not conducting. There is no current through inductor. So in mode 1, what is the inductor voltage VL? It is equal to, since inductor is conducting, so the voltage here is V in. So VL equals to V in. So this is equation number 1. And in mode 2, the inductor voltage VL is equal to, since now the diode is conducting and switch is off. So this point is at VO and this point is V in. Okay. So VL will be equal to VO minus V in. And in mode 3, the inductor voltage is equal to 0 since no current is flowing through it. Okay. Let us now apply the volt second balance. Volt second balance on the inductor. Okay. So there are two important relation or results: the volt second balance in case of inductor and charge balance in case of capacitor, through which we try to uh, realize many relations or obtain many relation between input and output voltage. So let me just admit this student. Okay. Okay, let's apply the volt second balance. So when in mode 1, the inductor voltage is V in, and the time for which this mode is applied is dt. Okay. Plus in second mode, the inductor voltage is VO minus V in, and the time is beta t. And in third mode, 0 into the time is your beta t, sorry, t minus beta t. And this has to be equal to 0. So this is the volt second balance. Average inductor voltage is 0 in one complete cycle. So if I try to solve this, V in times D plus VO times beta minus V in times beta is equal to 0. I can just remove T from each of the expression and take it on the right side. So finally, I get a relation between input and output voltage. So VO by V in will be equal to beta upon beta minus D. Beta minus D. So if you try to see this expression, so I won't be just analyzing it. I will be preparing a lecture to analyze this relation also. So right now, just remember that this is the relation in case of the discontinuous conduction mode. So now here we can find out, first of all, beta. Let us try to find out beta. Okay. Okay. So I know the output voltage, it is 150. The input voltage is 50, and I don't know beta, and then beta minus D I know it is 0.4, it is given. So this is equal to, this implies this gets cancelled, and this is now 3. So 3 beta minus 0.4 into 3 is equal to beta, and finally I get beta is equal to 0.4 into 3 divided by 2. So this will be 0.6. So beta is coming out to be 0.6. Okay. So here you could see that this is beta, and it is coming out to be 0.6. So this was 0 to dt. So this was 0.4, and now D was 0.4 and beta is 0.6. So what remains? So total is 0.6 from 0 to beta t. So remaining is 0.4 naturally. Okay. Now, now let us try to solve the problem. Come to the problem. The problem is to find out the power that is transferred from the input side to the output side. Okay. So let us try to solve it. Okay. So you could see from this figure here, from this figure, uh, let me call this as I2. The peak value of the inductor current is I2. It starts from I1, which is 0 in case of discontinuous conduction, and it reaches the value equal to I2. Okay. So what would be the average value of inductor current IL? Okay. So just let me tell you what we intend to find. So you could see that we are basically interested in in finding out this current IL, the average inductor current. Okay, because we know this voltage, this is 150 volts, and if we could find out the average inductor current, okay, then the product of the two will be power that is being transferred to the secondary side. Okay, instantaneous power, and finally the energy we can find out which is being transferred from the input side to the output side. Okay, so let us try to find it out. Okay. Okay, so let me bring this here and let's try to find out this I2. I2. So how to find it out? From 0 to dt, VL is equal to the input voltage, V in. Okay, so this is for mode 1. And VL is L di by dt, and this is equal to V in. And di is the change in current, which is I2, because I2 minus I1 is I2, I1 is 0, divided by dt, and this is equal to V in by L. So I2 will be equal to V in, which is 50 times T, D is 0.4, and T frequency. Frequency is also mentioned in the problem. It is given 5 kilohertz. So that means 1 by 5 kilohertz is, sorry. So it would be 5 kilohertz. So 1 by 5 into 10 to the power 3. Okay, so this is T, and times L. L is again given, it is 5 millihenry. So 5 into 10 to the power minus 3. So finally, this would come out to be, again, someone is trying to seek access. Let me admit him. Okay, one more student. Okay, so how much it will be? So this will be, so let me write it in terms of T only. So let it be T. Okay, so it will be 0.8 0.8 times T. Please calculate it. Can you tell me what is this value? how much it is coming. Let me just use calculator.
सर I2 कहाँ से आ गया सर?
I2.
Yes sir, I2.
You see, I2 is here. So Di is the change in inductor current. Okay.
जी सर.
So change is from I1 to
From
I2.
I1 to
So Di is for average value and instantaneous value will be same. So
जी
Di
सर.
is delta I, and delta I is equals to I2 minus I1. I1 is 0, so it is I2. Okay.
आंसर 0.8 ही आएगा सर ये.
0.8 आ रहा है.
हाँ
Okay,
सर.
okay. So
ये तो
0.8
0.8 आएगा.
amperes.
Yes sir. Okay.
So let me move forward. So I2 is 0.8. Now for this boost converter, uh, this battery will be getting power only when this switch is off, isn't it? So this battery will be receiving power from the input side, this 50 volt input DC supply, only when the switch is off. Otherwise, the power in the interval from 0 to dt, there won't be any power transfer from 50 volt input supply to this 150 volt battery, isn't it? So that means we are interested only in this interval. Okay. So finding out the value of the current which is flowing through the output, let me call it I naught. So I naught will be the average value of this, isn't it? So let us try to find this out. The I naught will be equal to area under this curve. Okay. So this is equals to half of this is 0.2t into 0.8. So this will give me how much? So 2 gets cancelled, and this is 0.1 and 0.1. So finally, it will be 0.08 t. Okay.
सर वहाँ पर सर BT हो.
कहाँ पर?
सर I नॉट निकालने के लिए सर 1/2 into BT into delta I.
1/0 into
बीटा T. तो सर
बीटा
0.60
टी
होगा.
नहीं होगा यहाँ पर. यहाँ पर देखिए हमको ये निकालना है. वी आर ट्राइंग टू
सर
फाइंड दिस.
सर
ओके.
वो जो
तो एरिया अंडर दिस ट्राइंगल. So this is 0.6 and this is 0.4. The difference of the two is 0.2 t. Correct me if I am wrong. So 0.2 t into this is 0.8, isn't it? So finally I am getting So this is the average output current. (150) into the output current, and the output current for the interval from d, d, dt to beta t. Just wait 1 minute. Okay, there was some disturbance. So okay, so 150 into integration from dt to beta t I naught dt. Now this is equal to 150 into 0.08 t, isn't it? So this is the, what is this? Area under this curve. Okay. So this will come out to be how much? It is,
Sorry, 12.
it will be 12
12 T.
12 t watts. Okay. ये t, अच्छा sorry, t term will not be there because ये divided by t होगा. Sorry, just a minute. यहाँ पर जो average inductor current होगा, it will be 1 by t times this. Okay. So this t and divided by t term will get cancelled and you will get 12 watts. ठीक है. यहाँ पर हम एवरेज पावर ट्रांसफर की बात कर रहे हैं. सो आई हैव टू टेक 1 by t here. Is it okay? So the power transfer from the input side to the output side is 12 watts. Just let me, if anybody has got any doubt in this problem. Any doubt? Yes.
This question will be uploaded or on YouTube?
I will be uploading this lecture on YouTube.
Okay.
Okay.
ओके सर, विद क्वेश्चन आप अपलोड कर दीजिएगा इसको, जो आया तो